Welcome. This is section 1.8, Miss Quinn's Geometry. And today we're going to talk about betweenness and distance. A point is between two other points if it is on the same line and its coordinate is between their two coordinates. For example, look at the line at the bottom of the screen. Hopefully you would agree with me that point A is between points S and F. It's also between points S and R. But point R here is not between S and F. Does that make sense? So betweenness is what it sounds like it is. We have some definitions for you to write down. The segment or line segment with endpoints AB denoted, remember when we write a line, we always write the line above it, AB with a line above it. Unless we're talking about length, then that line is gone. So we have line segment AB is the set consistent of all the distinct points, A and B, and all the points between. It's going to look like this. Here, if I don't have any arrows written, that means that I have endpoints at A and B. This line includes those endpoints and everything between. Array with endpoint at A containing a second point B is denoted as A with a B with a line and an arrow continuing over B. This means that I have some line segment that starts with A and contains that point, has everything between it, and then it keeps going after B and contains all the points beyond B. This ray, AB, contains line segment AB and more. Obviously, the more are the points beyond B. Rays A, B, and ray BA are opposite rays if and only if A is between B and C. We'll talk more about rays, line segments, and betweenness tomorrow. Let's talk about distance postulate. Let's go ahead and write this down. We have a uniqueness property on a line. There is a unique distance between 2 points. That means if I look at 2 points and I find their distance, I need to find the exact same distance every single time. The distance formula is simply the absolute value of their difference. I'm going to subtract their endpoints and then take the absolute values of that. Our additive property for the distance postulate says if B is somewhere on line AC, then AB plus BC equals AC. Let's do a real world example of this one. Let's say my A value is at 5, and my B value over here is hanging out at 11, and I have C up here at 16. Now, if I want to find the entire distance from A to C, I can add the distance from A to B plus the distance from B to C. The distance here between 5 and 11 is 6, and the distance here between 11 and 16 is 5. And then we're simply going to add those distances. If I had 6 plus 5, do you agree I would get 11? And hopefully our endpoints here make it pretty obvious. 5 plus 11 is 16. That's why I want to do something easy for this first example. When we deal with negatives, that concept helps us because those distances aren't as obvious. So for tomorrow, on a separate sheet of paper, I would like you to bring in this problem. If the distance between L and N is 49, and the distance between L and M is 26, M is between L and N, I would like you to find the distance between M and N. All right, I'll see you tomorrow.